Hi guys, today we're going to be looking at another beautiful topic on mathematics known as surd. So when we talk about surd, what is surd? Now surd is derived from a Latin word called surdus, meaning deaf to reasoning or mute. So we're going to be looking deeply into this as we progress. So this surd received a major work by Islamic mathematicians such as Abu al-Azan and Ibn Ali al-Khalasadi and got advanced by Christoph Rudolph in the 15th and 16th century, respectively. So when we talk about surd, what we are looking at today is a very interesting part of mathematics, which comes in handy when we talk about a couple of things in mathematics, like there's no way you can work on quadratic equations and a couple of other things without having the knowledge of surd. So what is surd itself? Surd is mathematical term, or it's a mathematical term used to describe real numbers that are irrational in nature. So when we talk about surd, we're talking about irrational numbers. So under surd, all what we talk about are irrational numbers. So what are irrational numbers? Irrational numbers are numbers that can't be expressed in a simple fractional format. So there are certain numbers that we can't express in a simple fractional format. Numbers such as square root of 3, square root of 5, pi is 7. When you look at pi means 3.142 and so on and so forth. So when we say irrational numbers, we are talking about numbers that we can't easily write out. For example, square root of 25 is 5, square root of 16 is 4, square root of 64 is 8. We did that already in the previous exposition. But when we talk about irrational numbers, there's no way you can get a particular fraction. For example, square root of 3 will give you 1 point something, 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 a whole lot of numbers that we keep having, non-terminating decimal, or sometimes either repetitive pattern of decimals or non-repetitive pattern of decimals. So that's what surd is. So when you talk about surd, we are talking about this sort of numbers. And that's why it is derived from that Latin word called surdus, which is mute. That's mute in pattern, that pattern of having just natural result, natural fractional result. So we're going to be looking at the different types of surd. So we're going to be considering different types of surd. The first we have is what we call the pure or the simple surd, such as root 5, I beg your pardon, square root of 3, so and so on and so forth. Now, these ones are called simple surd or pure surd because of the fact that we just have, as you can see, they are simple. There's no attachment. These ones in square root, they are known as radicand. You understand? This root 5, this root 3, root 11. Don't forget that when we talk about surd, we are talking about numbers that they are not perfect squares. For example, square root of 16 is 4. Square root of 16 or root 16 is not a surd really, because of the fact that we are going to end up having a given rational result. But for the surd, we are talking about irrational numbers. When you try to get the square root of these numbers, you end up having repetitive decimals or recurring decimals. So the next we have is mixed surd. Now we call this mixed surd because of the fact that one part of it is rational and the other part of it is irrational. Don't forget that irrational numbers are numbers that have recurring decimals and you can't put them easily in form of fraction, simple fraction. So 2 plus square root of 3, this is irrational, or it could even be 2 root 3. Look at this, 3 root 5. The 3 is a rational number, while the root 5 is called radicand, which is the irrational one. So the other ones we have irrational and rational surd. Now the irrational surd and the major surd that we have, this root 7 is irrational surd, root 11 is irrational surd. That these two are irrational surd. They are mainly surds. Now root 25 is not really a surd, although we call it rational surd, but it's not really a surd because of the fact that we end up having a rational result. Root 25 is 5. Square root of 25 is 5. Square root of 7 will not give you a perfect result. We have to multiply this with another, root 7 to get ordinary 7, which is square root of 49. So the next we're going to be looking at is like surds and unlike surds. Now when we talk about like surd, now look at this, 2 root 2 and 3 root 2. 2 root 2 and 3 root 2, as you can see, they have the same radicand, root 2, root 2. So it's very easy for us to work on them. We're going to be seeing this when it comes to arithmetical applications of surd. So 2 root 2 and 3 root 2, this has root 2, this has root 2, and that's why they are like surds. Now when you look at this, root 3 and root 5. They are not the same. They are different radicands, and radicands are very important, just like algebra. So they are not like, they are unlike surd because of the fact that the radicands are different. So we're going to be looking at this also, which is binomial surd. Now, when we look at binomial surd, this root 3 plus root 5. Now, binomial surd are different from mixed surd. There's quite a clear difference, a conspicuous one. Now, what's the big difference between them? Now, when you look at binomial surd, we have two surds, being connected with an addition sign or with a subtraction sign. So this root 3 plus root 5. They are both surds. This is surd, this is surd, because they are both irrational, but they have an addition connecting them. Unlike the mixed surd, whereby one of them is rational and the other one is irrational. So that's a big difference between them. One is rational, the other one is rational. But for these, they are different. The two of them are both they are both surds that are connected with either addition sign or subtraction sign. So the last one you're going to be looking at is the compound surd. Now the compound surd is a very, very complex kind of surd. Here we talk about either mixed surd or binomial surd being brought together using multiplication or using division. As you can see, there's this 2 root 3 plus root 2 in bracket. Then multiply with root 3 minus 3 root 2 also in bracket. So you multiply them. So these are compound surd. So at this very point, we're going to be drawing the curtain on today's exposition. So I want you to really learn this. That's an assignment because in the next exposition, we're going to be needing them. So if you have found this very resourceful or helpful, I'd love you to subscribe to this very channel and share this exposition. Thanks.